Hi, welcome to my kitchen. So, I thought I'd do a few videos, if you like, to help you with some of the learning now that you're at home. And you can tell it's a geography teacher's kitchen because, yes, there's a map on the wall. And essentially, what I'd like to chat to you first about is this. So, this is the first lesson for the Year 10 remote learning, which is about the global atmospheric circulation model. So, apologies if it's a little bit echoey. I've got to work with what I've got. Anyway, so I thought I'd talk you through it. So you might find this is an image I just got from Google search, and I want to talk you through how air circulates in different parts of the planet, which helps you understand why different ecosystems are located in different places. So first of all, the main thing to consider is that the Earth is largely, the Sun is largely over the equator more than other parts, or it's strongest over the equator. So that means that the central part of the Earth, the equator here, is getting heated more than places further north or further south. So that means at this point, around the equatorial regions, you've got a lot of very, very warm Earth. That means it heats the air above it. And this red line here you can see shows that the air is rising from this point more than other places. So as that air basically rises, it starts to cool. You can see the arrows here turning blue because the air is cooling. What this is not showing is that as the air cools, it condenses, and so you're going to get a lot of clouds forming over this part of the Earth in a band all the way around this part of the Earth. Now that basically means that you get a lot of rainfall. So at this point here you've got low pressure. The air is warm because it's warmed by the hot ground. That warm air rises, it cools, it condenses into clouds here, and it rains in a band right across this part of the Earth in the tropics. And that's why you get a lot of tropical rainforest in this bit. So again, this is low pressure because the air is rising. Now in the Hadley cell, in the Hadley cell, and there's another Hadley cell here, what happens is that air then spreads north and spreads south away from the equator. And as it does that, that cooling air lost its rainfall, and then it sinks back down to Earth. And as it's sinking back down to Earth at this point, and at this point, so the southern parts and the northern parts of the tropics, as the air is sinking, that means any moisture in the air in the form of clouds evaporates because it gets closer to the warm Earth. So clouds evaporate, you've got clear skies, and there's no rainfall. So while there's low pressure in this central belt, further north and further south you get high pressure. And that means here, because the clouds are disappearing and evaporating, there's no rainfall, that means you've got high pressure areas, you've got clear skies, you've got low rainfall. And that's why further north and further south from the equator, generally you get the desert areas. So low pressure around the equator, high pressure to the north of that, and high pressure to the south of that. And that's really the first bit about why the general circulation model helps explain why there are different ecosystems in different places. And that's why, looking at the map of the world here, the equator runs roughly through the mouth of the Amazon, through here, and that's why you get the rainforest in this belt right across the central bit around the equator. And then further north you'll get the deserts around the Sahara Desert and the deserts in Arizona, and you get further south of that as well, so this area here, you get deserts, the Kalahari, and you get the Gobi Desert, that's the north, apologies, Gibson Desert here, and the Atacama Desert in Chile. So, one thing that the global circulation model explains is the movement of heat further north and further south from the equator. And that means that without this, the central part of the Earth would be extremely hot, and the further north and further south areas would be much, much colder. So it attempts to even out the heat across the planet. So hopefully that helps a little bit.